know. Hey, suburban kids in Ohio. I hope everything's going well there. Mama, it doesn't have much to do with you. No, there are actually apparently some calculus kids in Ohio who are watching the video on a regular basis because their calculus teacher's on maternity leave. So they watch the video, they're getting the packet, they're doing all the things, they email occasionally. It's really kind of an interesting dynamic.
Are you getting paid for this?
No, I can't. But in that place, it's called the, what's it called? The heart. Yes, where most of you have a heart, I would feel warm and fuzzy for that. All right, so things that need to be known. BC students, you guys are starting your quiz at 9:09. Use this time, go over all those derivative rules, make sure you know what is going on. I got your work, I haven't had a chance to score it. Okay. AB friends, congratulations. We are starting the third unit of the course. I am so excited about this. It is the unit is called Rules of Differentiation. It just means derivative rules. That's all. That's all. Right now, you basically know one derivative rule. Anybody remember it? We know the power rule. And the power rule is when you're finding derivatives of things like x to a power. And what does the power rule tell us to do?
Bring it down.
Bring the power down
And subtract it by 1.
and reduce that power by 1, except we would be much more animated. What the power rule says, and we're all going to do this on the count of 3, what the power rule says, 1, 2, 3, if we have x to a power, what do?
We bring
Bring the power down.
and
Reduce the power by 1. And you guys know that. It makes you feel so good. You're like, oh my god, I'm so smart. I know the power rule. Good. That is one derivative rule. There are about 20 more coming your way. Because right now, the only thing you all are equipped to find derivatives of are baby problems. Baby problems like this one over here. And I realize I just had you guys pick up the new packet. I'm on page 5. I would expect that for everybody in the house, this is about a 3-second problem. About 3 seconds. Even if you're going slow, it's about 3 seconds. Okay, so since it's been 3 seconds, everybody's going to be able to tell me what the derivative of x cubed minus 4x squared minus 5 is. Go for it.
3x squared
Minus 8x. What about the 5? The 5 is a constant, and we know that the derivative of any constant is equal to 0. I use the power rule over here. I brought the power down. I reduced the power by 1. Over here, I brought the power down. I reduced the power by 1. Derivative of the constant is going to be equal to 0. I would hope this is way easy for us. Way, way easy. And that your notation is really good. If this is f of x, f prime of x is equal to the stuff. Pretty good? Okay, you have got the next 7 minutes to work on the next 4 problems. These are much harder questions. These are more appropriate for your smarticle particles. Let the cups do the talking. If you need some support, whoever is the shortest person in the group, you're in control of the cups. Yay, Karina. Green, things are good, no problems whatsoever. Yellow, you have maybe like a little bit of an issue. Red, we're in crisis mode. Enjoy the ride. Chris, you are so not the shortest person. 7 minutes, show me what you can do.
I can't never win,
Huh?
I can't never win. You will be the shortest person here.
Well, you could grow.
No, I'm just more shorter than I am.
3, 6,
I'm
9,
technically
12, 13, 19, 21, 22,
I'm above the average.
Okay. Axel's missing from the BC crew. From the AD crew, we're missing
And Diego.
Henry
Okay.
and Diego. Somebody else is missing. And Gonzalo again. If he comes back with different color hair again from being absent, circus boy crazy. 6.5 minutes left. Don't waste the time.
-4 over 2 t to the third power plus Yeah.
Would it be 3?
Then it will be
No, for this.
negative 6 to the 3i where equals negative 2 to the 4.
It's not like this.
No, I'm still on the first one.
18.
Yeah, you're right.
18.
You got this. Have a fun this class. It doesn't affect you. No, it doesn't affect you. What would you pay? For like, class of over 95.
What is this? So,
Oh, sad panda, I just walked by 4 different people who are not reading number 2 carefully enough. You're finding something, but it's not what I'm asking for.
so it's 8 theta?
Yeah. Nine.
Wait, it's gonna be or is it gonna still have the 3 beta?
Okay, I see yellow.
What is
Here,
this?
talk to me.
So this one, we know it's 8.
Wait. Is this gonna be 8 beta or is it?
It's 8 theta. How do you know what's the theta? Oh, theta equals 1. So 8.
Oh, you're right.
Imagine.
Minus 3. Because remember this is 1.
And would be just.
That's all?
It's a
Oh, that's 3, yeah. There's 9, like I times.
Same thing.
Careful though, because I think I'm asking. Then you have to put in 1. Yes. So is this a group? Okay, what's that? Once you find the derivative, then you plug in 1.
You find
That's not
the
the derivative. And I know it
zeros
makes
from
sense.
the
But you're here
derivative.
because I've changed up the variable, right?
and that's the time.
If this was 4x
No,
squared
yeah.
minus 3x,
Yeah. Oh, you find zeros.
it would be 8x
all you
minus
do.
3. Because the theta is the variable. You'd say like theta to the first power, you bring the power down, reduce the power by 1. We're doing okay? Friends back here?
Oh, yeah, I see it. I think it's psychic. Kept it the same.
So you
I don't know
put
why.
minus.
No, yeah.
Right?
That's what it says.
And pi.
So they did, but it's probably
Take the x squared, right?
0
No, exactly.
is plus or minus
You're not going to.
Nice. I'm liking what I'm seeing.
Oh, yeah, yeah. Square root of 3 plus or minus 6.
Oh, yeah,
Plus or minus 3.
No, it must change.
Look at this.
Yeah. Friends over here, how goes it? Feeling good? Jesus, you doing all right? Good. Okay, ladies over here. Oh my God, we're in crisis. Okay, why are we in crisis?
Because I think like if we all
So I think you're thinking L of X is like tangent lines.
yeah,
But I'm specifically asking for where you would make a horizontal tangent line. What's so special about a horizontal tangent line? What's equal to 0? The derivative is equal to 0. So if you have a horizontal tangent line, the derivative is equal to 0. So what I would recommend that you do here, you know what the function is, right? you need to figure out where the derivatives equal to
That's why I
zero. So
don't
what are you
use
going
this
to do,
one
Andy?
also. Like I double check.
Oh, no. Oh, just pretend.
All I need to know is where you have horizontal tangents. Find the derivative, set it equal to 0. Done. Yep.
So for this one, no, but see, I got here before, I swear.
So why are you
You have to find no, x prime and x prime and then x double prime.
found the second derivative? Why did you do that?
What is that acceleration? I know that's like velocity, right?
Well, I know.
And then you have to find.
All right, friends, if you could grab markers out of the container, please.
Yeah.
Okay. This is not for a grade. This is just a little bit of feedback for you. Okay. So I know everyone's got the first one right because you blindly copied what I did. No. All right. So number 2, g of t negative 1/2 t to the 4th plus 3t cubed minus 2t, g double prime. G prime prime. A lot of you found the first derivative, and that was great, but then you stopped. Okay, so the first derivative, negative 2t cubed plus 9t squared minus 2. Second derivative, negative 6t squared plus 18t. How are we doing with this? Okay, now here's the thing. I saw a couple of people who had f prime of x and f double prime of x. How am I feeling about this? Jose, what's wrong with this? What's wrong with this?
It's G prime and G double.
Not only have you decided that you don't like the name of my function, you don't like my variable. I don't like that. Please don't change my things. The College Board is going to say, oh, how cute. Wrong. Labeling is essential. Okay, yes, and then because not only do we take derivatives of functions in terms of x's and t's, sometimes I'm going to go cray-cray, and we're going to use theta. Derivative of 4 theta squared minus 3 theta is 8 theta minus 3. dh d theta at theta equals 1 means once you find your derivative, plug in 1, good news, 5. Okay. H of x is this function over here. Determine the x-coordinate of horizontal tangent lines. Little note to myself, horizontal tangent line means h prime. The derivative has to be equal to 0. So I'm going to find the derivative, set that equal to 0, and then your calculus is done. There's no calculus to do. It's just your algebra and your pre-calculus. And since I've known those teachers, I know those skills are strong. Maybe you factored out the 5x squared, now it's 5x squared times x squared minus 3 is equal to 0, and your roots are 0 and plus minus square root of 3. Here's, how many guys got 2, 3, and 4 perfect? Okay, we're in a good place. Maybe you got like 2 out of the 3. I can deal with 2 out of the 3? All right, and I saw just a few folks made it to number 5, and I can deal with that. Number 5, a particle travels along the x-axis in such a way that its position can be determined by the equation x of t, 3t to the 6 minus 15t squared plus 12. Determine whether the speed of the particle is increasing or decreasing. It's been a couple of days, and you might be like, oh my god, wait a second, this was all last unit. Why are we having conversations about that in this unit? Because calculus is cumulative. We keep building. You know position. How do you figure out if speed is increasing or decreasing? I see 1, 2, 3, 4. How do we make decisions about speed increasing or decreasing?
You find the derivative of that, and then make it that to the value.
So you want to find the derivative of, you said that, you meant find the derivative of, which is the position. And everybody knows derivative of position is?
Velocity.
One more time, everybody knows derivative of position is? Velocity. What else about?
Then you like put absolute value. Like,
Oh, sad panda. sad panda. We definitely need to look at, we know position. If you take a derivative, you're going to get velocity. And speed is the absolute value of velocity. But if I want to know if speed is increasing or decreasing, Karina, what do you need?
You have to find acceleration too.
You also find acceleration. You have to look at both the velocity and the acceleration. You have to look at the sign of both of these. And if the signs are the same, they're both positive, speed increases. If the signs are different, speed decreases. So to finish this off, and I saw Paul did a great job with this, he figured out the velocity, 18t to the 5th minus 30t. He figured out the acceleration, 90t to the 4th minus 30. He evaluated the velocity at 1, evaluated the acceleration at 1. Velocity is negative, acceleration is positive. Conclusion? Velocity is positive, acceleration is negative. Yes, it says speed is decreasing, but if velocity and acceleration have different signs, speed decreases. Okay? And if anybody got to number 6, we're not going to talk about number 6, but that's what your final answer would look like. Okay. So that was meant to be the nice, friendly, make you feel good about your calculus skills review. Sorry, Sylvia. That was the fun part. And now it's time for the push. There's always a push. We're going to go until 9:30 with this next part. And you all are going to be just fine. Just fine, Chris. I have no new derivative rules for you today. I am deliberately holding back. Why? Because I want to see how good your algebra skills are.
You have like 4 different algebras.
I know, it was a tough year for you guys back in algebra. But that's okay, you have me and I can close all the gaps. Except gaps in teeth, I haven't figured that one out yet. Okay, so, I got jokes, thank you. Even kids in Ohio are laughing right now, they don't know why. All right, so here's the thing. All the problems that we're going to look at for the rest of this period are going to be a push in a whole different direction. Because right now, the only thing you know how to find the derivative of is stuff that is like something to a power. Hi, Jeanette, what's up?
When you go on to a number,
I was hoping you guys were keeping track of your own time out there, since I'm a little busy in here. Okay, never mind. Bring it back to me, okay?
yes.
This is the only derivative rule that you know. The BC friends know about 20, and they're in the process of showing me how many of them they actually know. This problem over here, this first one, f of x equals 2x cubed minus x, the whole thing squared, is not what I would say derivative ready yet.